Hello and welcome to another video. In this video we're going to be working on the nth Tribonacci number. And in this problem you have a Tribonacci sequence which is like Fibonacci except t of 0 is 0, t of 1 is 1, t of 2 is 1, and t of everything else is just the three numbers before it. So t of 3 is t of 0, t of 1, and t of 2, and so on and so on. So for n equals 4, they basically tell you how to do this. So if you think about it, t of 4 equals t of 3 plus t of 2 plus t of 1. And so if t of 1 is 1, t of 2 is 1, and t of 3 is t of 1 plus t of 2 plus t of 0, which is these three combined. So t of 3 is going to be 2. So you just add all these together. And t of 25, they give you some number. So there's a bunch of ways to do this, and this is basically like the easiest kind of DP problem you can have. So one of the ways to do it is recursively. And instead of the Tribonacci, let's just do a Fibonacci example. So we'll just say like t of 0 is 0, t of 1 is 1, and then t of x is x minus 1 plus x minus 2. Just to keep it simple, and then we can basically do the exact same thing for the third number. So one thing you can do is you can do this recursively. So if I want, like, let's say t of 20 or n of 20 or whatever, so let's say I have 20 here. Well, I can just do 19 plus 18. And then to get 19, I can do 18 plus 17, and so on and so on and so on, and you would just basically keep going. And so to get every number, you would just make a recursive call and get the sum of the next two. But the problem with that is you're going to calculate a bunch of numbers a bunch of times. So you could see, like, to get 20, we needed to calculate 19 and 18. Then to get 18, we are calculating it again, and we calculated it here. 17, we calculated, and so on. And so if you draw out this whole tree, you're going to calculate a bunch of these numbers a bunch of times repetitively. So the way to avoid the repetition is you can do this recursively, and you can store as results. So for example, when we calculate 18, like t of 18 or Fibonacci of 18 or whatever, we just store that in a cache. And then, so we'll calculate it here, and then when we try to access it here, we'll have it available. So that's one way to do it. You could do it recursively with a cache, and then that way you only have to calculate each number once. Another way to do it is actually building from the ground up to getting your number. And so we can even show this for the Tribonacci now. So let's say we want, like, the 9th Tribonacci number. So we could do this recursively, right? Where you could say, like, okay, give me the 8th, the 7th, and the 6th, add them together, and then return the result. And then for the 8th, you would get, you know, the 7th, 6th, 5th, and so on. And you would just do this in a cache. But the better way to do it, well, not the better way, but another way to do it is if we wanted, so this is 0, 1, and 1, right, I believe. Let's take a look. Yeah. So what we can do is we can say, okay, now that we have these three, we're just going to build up for this number. So what's the third number? Well, it's going to be the 2nd, 1st, and 0th, and we have those already, right? So it's just these three added together, which is 2. And then the 4th number is just the 3rd, 2nd, and 1st, and we have those already. So this is 4. Then the 5th is these three, so it's 7. And then the 6th is these three, so 13. And so you notice we don't need to do any kind of caching because we can calculate each number quickly, right? Because we're starting from the base cases, we have everything available right away. We're starting at the one we have to calculate, and we have to go down to the base case. So this would be equivalent to top-down dynamic programming. And this, and because it's top-down, because you're going from your top to the base case, and this is bottom-up dynamic programming, because you're starting at the base case and building up to your solution. So if we keep going here, this is going to be 24, and then 41, actually not 41, 37, 44, yeah. And then this is going to be 78, 81, I think. So maybe I miscalculated somewhere, but essentially you kind of get the idea. So to get a number, you just take the 3 before it added together. Now notice that to get a number, we only need the 3 before it. So let's say if we wanted t of 9, like this Tribonacci number of 9, to calculate it, we only need these 3. Then to get this number, we only need these 3. To get this number, we only need these 3. So we don't need to store this whole array. What we can do is we can just store 3 numbers. So we'll kind of do the same thing. And we're just going to store the first 3 numbers, and that's it. So we'll store 0, 1, 1. Now we basically have to figure out how many more numbers do we need to calculate to get this. So this is 1, 2, 3, 4, 5, 6, 7. And you can kind of figure that out, right? Just do some basic math. Like if I want the 9th number, I have the first 3, so I need whatever, like 7 more or something, or 6 more, 7 more. So because it starts with 0. So if I want the 9th, I would subtract 3, add 1, something like that, right? And so that's kind of the thing. So now what we can do instead is basically to get this next number, it's going to be the sum of the first 3. And then we no longer need this, right? So to get this number, we need to sum up these 3. But then we no longer need this for any future calculation. So we're going to get these 3, we're going to store it, then we're going to get rid of this, because for this number, we only need these 3. So, and then we basically do this operation 7 times, right? So we need to calculate 1, 2, 3, 4, 5, 6, 7. And then our last number will be this 9. So what that's going to look like is, first, we will store a temporary result, which is the sum of all these 3 things. So that's 2. Then we kind of shift these over. So instead of having these boxes, instead of having these indices, basically we store a result, we get rid of the last one, and then we put in the 2. So this will be 2. And so we have to do this. Like I said, we can figure out how many times we have to do it. We have to do it 7 times total. So that's once. Then another time, add all these up, you get 4. And then store the result. Okay, so we have to do it 5 more times, add all these up, you get 7. Get rid of the last one, 7. Add all these up, so you can tell from here you'll get 13. Get rid of the last one, 13. And then you just basically keep doing this. So you add all these up, get 24. Get rid of the last one, store 24. Add all these up, get 44. Get rid of the last one, store 44. And finally, last one, add all these up, get 81. And then, so this was like the 0th, first, and second number. Now, the second number that we have will be our answer. So that's how you can do this space optimized bottom up. You basically realize for every number, I only need to store the last 3. So once I calculate like this number from these last 3, now I can get rid of this guy and just store these 3. Then for this guy, I need these 3, so I can get rid of this for the next one, and so on, and so on, and so on. And so your last numbers basically represent these right here. And then your answer will just be this one over here. So that's the solution we're going to code. So we'll store 3 numbers, and we'll have our base cases. So if n is 0, we'll return 0. If n is 1 or 2, we'll return 1. And for everything else, we'll just do a loop. So let's do that. And let's just make sure actually that that's what they're asking. So for n equals 4, yeah, so for n equals 4, we'd want to return 4 and so on. Yeah, and this can be 0 to 37. Okay, so we can say if n equals 0, let's just return 0. If n is less than 2, let's return 1. And now we can store our 3 numbers. So we can have like a first, second, and third number, or you can make an array. Either one's fine. So you can make an array of 3 numbers, or you can store these in variables. I guess let's just store them in variables. So we can say like int 0th or something equals 0, int first equals 1, int second equals 2, or 1. Now we basically have to figure out like how much we have to loop. So for 9, we needed 7 numbers. So for a given number n, we need n minus 3 plus 1, I believe. So like for this number, it would be 3 minus 3, and then we need one more operation. So we can just loop. So for int I equals 0, I is less than n minus 3 plus 1. So that's how many times we need to do it. And then, yeah, basically now what we do is we have a temporary thing, which is the sum of all these. So we can just say like temp equals 0th plus first plus second. And then we kind of shift these around. So if you notice, if we have these three numbers, what's going to happen here is first will, or 0th will be the new first, right? So it basically goes like this. So first will be over here, or 0th will be the old first will be the old second, and second will be the total. So that's the idea. So we can say, and let's think of, yeah, so we want to do first equals second equal, 0th equals first, or like I said, you can have an array or a queue to do this, but it's only 3 numbers, so you can use variables. First equals second equals temp. And now our answer will be in our temp, and our last 3 variables will be like the last 3. So if we have like n equals 10, then this will be 8, 9, 10. So now we just return second. So that's the in-place solution. And yeah, the idea is basically to recognize that when you do a bottom-up DP, how many numbers do you actually need to store? So because every number only needs the last couple, only needs to store the last couple. So that's why if you do like a factorial or anything like that, or like a Tribonacci, or anything that relies on the last few, instead of storing the whole array, just store the constant amount that you need and just keep iterating on it. And yeah, so pretty easy. And if this is the best way to do it. You can do the recursive with a cache, but in this case, this is constant space, so it's going to be better. And so time now, so because like it's pretty easy to figure out that our time is just basically O of n, because every single number is calculated in constant time, right? We have these three base cases. Then every single number is just a constant time, add the previous 3. So it's just O of n. And space is O of 1. And this is a similar pattern to a lot of like the easier DP problems. The harder DP problems, you will usually have a 2-dimensional array, and then you can get rid of 1 dimension fairly often by doing the space thing. But yeah, it's going to be all for this one. So good intro to DP. Definitely, if you haven't done DP before, would encourage you to code this up in all the ways. So start with a recursive solution. I think recursive might even fail with no cache, but then make a recursive solution with a cache. Then make an array solution, and then go make the constant space solution after that. Good practice, because these problems only get harder. So if you can't do it for this one, it's going to be tough for you for harder ones. Hopefully this is helpful. If it was, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.